Okay, so when we're simplifying, when we're involving radicals and fractions, there are a couple of rules. First of all, we cannot leave a fraction under a radical. So I'm going to just move this up to show you a minute. So what I mean by that is I can't have like a square root of a fraction. Okay, that's not completely simplified. You also cannot leave a radical in the denominator of a fraction. So I could not leave something that was like some number over a radical, square root, cube root, whatever. And then we also cannot leave a perfect root under the radical, which is what we've been doing for the past 2 days by simplifying. Okay. So with that being said, we're going to start with number 1. I have 6 over the square root of 5, which is not simplified. So there's what we have to do is called rationalizing the denominator. I have to get that radical out from under the denominator. So with a fraction, we can either multiply or divide the top and the bottom of a fraction by the same thing, and it will be an equivalent fraction. It'll just look different, right? So we're not going to focus on the dividing part. We're going to focus on the multiplying part. If I want to try to get that square root of 5 out of the denominator of that fraction, I need to be able to multiply it by something that's going to turn it to a perfect square so that it then simplifies. If it's a square root, most of the time you just multiply it by itself, right? So if I have a square root of 5 in the denominator and I want to get rid of it, I'm going to multiply the top and the bottom by the square root of 5. Okay, so that's what we're going to do. Whenever I multiply the bottom by, I have to multiply the top by exactly the same thing. One thing we need to be careful of is when I multiply that 6 times that square root of 5. Is the 6 under the radical? No, but the 5 is. So we can't technically multiply those and get like the square root of 30. But we can multiply them. That 6 is just going to stay where? Out in the front, yeah. So it's going to be 6 times the square root of 5 at the top. And then at the bottom, the square root of 5 times the square root of 5 turns to the square root of 25. Now I'm showing all my work. A lot of you who understand and remember how to do this might not show this step. Then I need to simplify. I'm going to keep the top the same. What is the square root of 25? 5. So that denominator is going to turn to 5. And then I'm going to see if I can simplify any further. I'm going to start with the 2 numbers that are not under the radical, the 6 and the 5. They have anything in common that I can divide out? No. And then I just want to check the number under the radical. Does 5 have a perfect square that divides into it? No. So that is as simple as the answer can get, and I leave it just like that. So go ahead and try number 2 then. Same concept. I don't want to keep a square root of 10 in the denominator, so I have to figure out what to multiply by so that that square root of 10 simplifies to be something that is not a square root. So if I have the square root of 10 in the denominator, and I need to make it a perfect square, I'm going to multiply it by itself. So the square root of 10, right? Again, at the top, the first 10 is not under the radical. The second is, so we can't technically multiply those by changing the number. We just put it as 10 square roots of 10. And the square root of 10 times the square root of 10 is the square root of 100. I'm going to keep the top part the same for now. What is the square root of 100? What does that simplify to be? Just 10. Some of you may go directly from the multiplying by the square root of 10 to that step that I just wrote. You may realize that when I multiply a square root by itself, it just turns into that number. Is there anything I can simplify here? Check the numbers out that are, out front, the ones that are not under the radical. Do I have numbers that can simplify? Yes, the two tens that are not under the radical can divide by 10, so basically they just do what to each other? Cancel. Which leaves me with the square root of 10 at the top, nothing at the bottom. And then the only other thing I would want to check is, can the square root of 10 simplify? Do any of these perfect squares divide into 10? No, so I would just leave my answer. You can leave it over 1 if you want to, but you can also just leave it as the square root of 10. Any questions so far? Okay. All right, now, number 3, you'll notice I have an entire fraction under an entire fraction under the radical symbol. So that is also not allowed. The very first thing I recommend doing is I split it up. And what I mean by that is take the square root of the top and the square root of the bottom. Now, before I start going and multiplying the top and the bottom by the square root of 16, what do you realize about 16? It can be, it's a perfect square, isn't it? So would I really need to do that to be able to simplify it? No. You can. You would just have to simplify a lot more. But because that denominator is a perfect square, I can go ahead and simplify it to its square root, which is just 4. And then again, I'm going to try to simplify. Does the 1 in the front of the square root of 3 and the 4, do they divide by anything? No. Does 3 have a perfect square that divides into it? So that's just going to stay the square root of 3 over 4. Now, you could have done it the other way. Let me show you. And that's the thing with these, especially these fractions. There are multiple different ways that we can simplify them. It just really depends on what you see when you look at the question. But if we had done this, if we had simplified it to the square root of 3, and we had multiplied both the top and the bottom, can I actually multiply that 3 times that 16 here? I can, because they're both under the square root. Square root of 16 times the square root of 16 is the square root of 256. That turns to 16. But then remember also we always have to check to see if we can simplify, right? So here, the 16 is not under the radical anymore, so I need to see about that square root of 48. It is not on my list, so I'm going to see if any of these numbers divide into it. 36 does not divide into 48. Neither does 25, but what does? 16. So I would have to then split it back up. Simplify that square root of 16. And then what do you see that could reduce there? The 4 to 16 can both divide by 4, so that would turn to a 1 square root of 3. And that would turn to 4, which is exactly what we got. It's just a little bit more simplifying if you don't recognize that that denominator is a perfect square before you start. Okay. All right, I want you to try 4 then. This one is similar with the exception of my denominator is not a perfect square, so I am going to have to rationalize it. I'm going to have to figure out what I multiply by to simplify. And I'm going to change that because we will be dealing with some more numbers. Adding back those original ones that we put in, and then also just smooshing this together so I have more word space. So again, we have an entire fraction under the radical. So the first thing I'm going to do is separate it. And when I do that, again, I always check the denominator to see, is it a perfect square that I can simplify first, or do I need to continue? In this case, 5 is not a perfect square, so what am I going to have to multiply the top and the bottom by? Square root of 5, perfect. Now at the top, can I actually multiply the square root of 2 times the square root of 5 and change the number? Yeah, they're both under the radical, so that's going to turn into the square root of 10. The denominator is going to turn into the square root of 25. I'm going to keep that numerator, and I'm going to simplify that denominator. Right now, I don't have a number in front of that square root of 10 other than 1, so that doesn't simplify with my 5. But I do need to check the 10 to see if it can break down a little further. Is 10 on my square list? Do any of these numbers divide into 10? So that's going to be as simple as it gets right there. Now 5 can also be done a couple of different ways. I would like for you to try it so I can see if any of you use the 2 different approaches that there are. Now, our square list only goes to the 15th one, so when you're working with these bigger numbers, you might want to use your calculator. So I actually I said there are 2 ways. There are technically 3, and I saw all 3 of them, which is good, because that means some of us understand the concept of what we're trying to do. Most of us, separated the 5 and the 18, and we multiply the top and the bottom by the square root of what? 18. Okay. So at the top, let's see, that's going to give me the square root of 90. At the bottom, that is the square root of 324. So we get the square root of 90 over 18. Okay, and then I had a couple people left it like that, and I said just make sure you continue to try to simplify. 90 is not a perfect square. So what I want to do is look at my square list and find a perfect square that might divide into it. 81 is not. 64 doesn't. 49, 36, 25, 16. But 9 does, right? So we can split that up into the square root of 9 times the square root of 10. And that is going to give me, the square root of 9 is 3. Square root of 10 over 18. I did have a couple of people starting to leave it like that, but we got to remember to try to simplify. The numbers that are not under the radical, 3 and 18, they can both divide by 3. So that 3 will turn to a 1, and that 18 will turn to a 6. So that's one way. Okay, but I'm going to show you the other two because you might like those a little bit better once you see how they can work. So I'm going to start again with the square root of 5 over the square root of 18. A couple of us recognize that 18, although it is not a perfect square, doesn't 18 have a perfect square in it? Yes. So some people say, well, let me simplify that first so I'm not dealing with such large numbers. And what they did with that was they separated that into the square root of 9 times the square root of 2, which turned into the square root of 5 over 3 square roots of 2. Now, why does that help? Because what's the square root I need to get rid of now? What's under the square root in the bottom? A 2. So, instead of multiplying by 18, I can multiply by a much smaller number. 3 times 1 is 3. Square root of 2 times square root of 2 is square root of 4. Square root of 4 turns to 2. That gives me the same answer, right? I just didn't have to deal with such large numbers. Does it make a little bit of sense? Now, there is another way. And you're going to have to start thinking about it like this once we change from square roots to cube roots. 18 is not a perfect square. But if I think about my perfect squares and I say, okay, well, is there something I can multiply 18 by besides 18, because that's a rather large number, that will turn it into a perfect square? So I'm going to start here. We got to start with numbers bigger than 18. Can I multiply 18 by anything to turn it to 25? No. Can I multiply 18 by anything to turn it to 36? 2. So what if I just multiplied the top and the bottom by the square root of 2? That gives me the square root of 10. That gives me the square root of 36. That square root of 36 turns to 6. And then I end up with the same number. I just didn't have to deal with such large numbers. Does it matter which way we do it? No. Whichever way makes sense in your brain is the way you need to do it. It's just when we start changing them from square roots to cube roots, you're going to have to start thinking about it more along the lines of this method, which we'll get to in just a few minutes. Does that make sense? Okay. Here we go. We have the cube root of 5 over 27. So I want to do the very first thing I did with question number 3, or any question that had fractions under the entire radical, is go ahead and separate it. Take the cube root of the top and the cube root of the bottom. And much like number 3, before I start trying to work on what to multiply by, especially since we're not used to the cube roots, let me ask you this question before I start trying to figure out what to multiply by. I cannot have that cube root in the denominator of a fraction, so I want to know, is 27 a perfect cube? It is, so I can go ahead and simplify that from the beginning. I'm going to keep that cube root of 5 in the numerator. And what is the cube root of 27? 3. So that gets rid of the radical in the denominator. The only other thing I will try to do is simplify. Do I have any numbers at the top and the bottom that simplify that are not under the radical? No. The number under the radical 5, does it have a perfect cube in it that can divide out? So therefore, we're going to just leave our answer as the cube root of 5 over 3. Bless you. All right. Now here's one we do need to think about. So I want to go ahead and write down number 7. Squares, you can always just multiply the number by itself because that turns it into a perfect square. It's a little different with a cube. To multiply a number by itself doesn't necessarily always turn it to a perfect cube. So we have to get on the thought process of how can I turn the denominator into a perfect cube? Again, the first thing we want to do is we want to separate it. The cube root of the top over the cube root of the bottom. And I'm going to ask myself, just like I did with number 6, is 4 on my cube list? No. So what I want to do is I want to work for the smallest numbers I can. I don't want to have to deal with big numbers. Okay, 1 doesn't work because you can't make numbers smaller. So I'm going to start with the next perfect cube. Can I multiply 4 by anything to turn it into 8? Yes. What would I multiply it by? 2. So we can multiply the top and the bottom by the cube root of 2. It doesn't have to be multiplied by itself because we're dealing with cubes, and we proved that with that last question up, or 2 questions ago. So if I multiply the cube root of 3 times the cube root of 2, that gives me the cube root of 6. And then the cube root of 4 times the cube root of 2 is going to give me the cube root of 8. And to simplify, what do we know the cube root of 8 is? 2. Okay. And then I just need to check to see if I can continue to simplify. No numbers outside of the radicals that can simplify. Is 6 a perfect cube? Does it have a perfect cube that can divide into it? No. So I would like for you to try 8. You have a cube root of 9 in the denominator. What you're going to ask yourself is, what can I multiply 9 by to turn it into a perfect cube? You can't go smaller than 9, so you have to start on your cube list with the first number that is bigger than 9. If that doesn't work, move down to the next one. And this is kind of backwards from simplifying. We're looking at smaller numbers here, not larger. A perfect cube list, because this is a cube root. Want to know what perfect cube can we turn 9 into. Once we decide that, then we figure out what we need to multiply it by to get it to that cube. I can't use 8 because that's smaller than 9, so I'll start with 27. Can I multiply 9 by anything to turn it to 27? So we're going to multiply the top and the bottom by the cube root of 3. Maybe. Now at the top, 5 times the cube root of 3 is just 5 cube roots of 3. At the bottom, the cube root of 9 times the cube root of 9 is the cube root of 27. I'm going to leave the top alone for now. What is the cube root of 27? 3. And then again, we just check to see if we can simplify. Start with the radical at the top. Is 3 a perfect cube, or does it have a perfect cube that divides into it? No. All right, then we can do the numbers outside. Does the 5 and the 3 have anything in common that I can divide out? Do we kind of understand how that works? All right. Try 9. Come on. That is a 6 in the front times the cube root of our fraction 1 over 3. Just keep that 6 in the front until you work on simplifying that radical, then we can deal with it in the end. Also with these, just like yesterday, if it has a cube as an index, you make sure that cube is an index in your answer. when I split my fraction up into the cube root of 1 over the cube root of 3, where does the 6 go? At the top or at the bottom? It's at the top, right? Because isn't that like 6 over 1? Okay. So I'm going to keep that 6 at the top. Again, I need to turn it to a perfect cube, so I'm going to my cube list. Can I multiply 3 by anything to turn it to 8? Can I multiply 3 by anything to turn it to 27? 9. Okay. So we're going to multiply the top and the bottom by the cube root of 9. That 6 cannot be multiplied, so it's going to stay in the front. The cube root of 1 times the cube root of 9 is just the cube root of 9. At the bottom, the cube root of 3 times the cube root of 9 is the cube root of 27. Keeping the top the same for now. What is the cube root of 27? 3. All right. Under the radical, is 9 a perfect cube, or does it have a perfect cube that divides into it? No. But what do you see that we could simplify? The 6 and the 3. Divide them both by 3. The 3 goes away. The 6 turns to a 2. So my most simplified answer is going to be 2 times the cube root of 9. You can put that over 1 if you like, but you do not have to. Questions? Okay, now we have to throw some variables in here. So let me ask you this. If I have a variable and I need it to be a perfect square, what does the exponent need to be divisible by? What's the index on the square? 2. Okay, so if my exponent is divisible by 2, that variable would be a perfect square. If I am doing the cubed root of a variable, that exponent would need to be divisible by 3, right? So let's keep that in mind. I hope I'm not ahead of myself because I think variables are next. Oops. Just kidding. We'll do 12. We'll go back to the other 2. I got way ahead of myself. Let's write down number 12. We'll go back and do 6 and, 10 and 11. Good grief. Separate it out. Do the square root of 5 times over the square root of x. Again, it's a square root, so we just said in order for that variable to be a perfect square, excuse me, the exponent on it is going to have to be divisible by 2. What's the exponent on it right now? On the x? 1. How many more x's would I need to make it divisible by 2? Just one more, right? So we're going to just multiply, and again, it's a square, so we could always just multiply it by itself. But at the top, that would be the square root of 5x. At the bottom, that would be the square root of x times x is x squared. Okay. I'm going to keep that square root of 5x at the top. What is the square root of x squared? 2 divides into 2 one time. Do you see anything that would simplify here? Now let me just give you a for example. This is not an, if I did this, if I did 2 over, let's say, x to the third, or I'm sorry, the square root of x to the third. The exponent is a 3. How many more x's would I need to make that an even number that would be divisible by 2? 1, right? So we would just multiply that one by the square root of x as well. So just keep that in mind. Yes, you could multiply it by the square root of x to the third. However, that's going to be more simplifying that we don't want to have to do. So I would like for you to try 10 and 11. These will be the last 2. Oh, just kidding. Well, yeah. Anyway, I'll be back. So I'm going to get you not looking at my examples before we start class. a little bit more involved with both of these. When, for example, like number 10, when you have a coefficient in front of the radical, like that 2 square roots of 6, you only have to get rid of the radical. You don't have to get rid of the coefficient. So when you're multiplying, you don't have to do the 2 and the square root of 6. You only have to do the square root of 6 as far as what you're multiplying by. The key here is just making sure we get this thing completely simplified. What would I need to get rid of in number 10? And then I'll do the square root of 6. So if I multiply the top and the bottom, maybe, by the square root of 6, at the top, that's going to be 5 times the square root of what, 144? Okay, and at the bottom, it would be 2 times the square root of 36. What do you notice about the square root at the top? It's a perfect square, right? What is the square root of 144? 12. And then at the bottom, the square root of 36 is 6. All my radicals disappeared this time, didn't they? Let's keep going. What's 5 times 12? 60. And 2 times 6 is 12. And those can both divide by... Oh, 12 goes into 60 a whole number of times, right? How many times? 5. Look at this. Let me show you something. There is another option. And if you don't like it this way, you don't have to do it this way. So you don't, I mean, if it confuses you, just don't worry about it. I can look, when I have numbers outside the radical and numbers inside the radical, I can also try to simplify first. Do 5 and 2 have anything in common? They don't, do they? Okay. What about the square root of 24 and the square root of 6? What do 24 and 6 have in common? 6. So if I were to divide 24 by 6, that turns to 4. If I were to divide 6 by 6, that turns to 1, right? What's the square root of 4? 2. What's the square root of 1? That's 10 over 2, which gives me... So I didn't have to deal with such large numbers? Keep going with 11 if you haven't finished it already. So when you have numbers that are both under the radical or either both but not under the radical, it might benefit you to simplify first so you don't have to deal with such large numbers. But if that confuses you, deal with them as they are. Good question. In the denominator, do I need to multiply by the square root of 4 at the top and the bottom? Do I have to? Why? 4 is a what? It's a perfect square. I could multiply by the square root of 4. Absolutely. However, 4 is a perfect square already. That would turn into 5 times 2. Now, before I work on the 6 and the 10, let's work on the 32. Because I'm going to have to simplify some more. 32 is not a perfect square. Going to the number closest to it without going over. Does 25 go into 32? Does 16 go into 32? How many times? 2 times. So we can split that up into the square root of 16 times the square root of 2. What is the square root of 16? And 6 times 4 is 24. And then what can both 24 and 10 divide by? 2. One more real quick. Not one more example. I just want to show you this one. Okay, in the beginning, looking back at the original question, the numbers outside, do 6 and 5 have anything in common? No, okay. What about 35, 32 and 4? Can I divide those both by anything? 4. So that would turn into the square root of 8 and the square root of 1. 8 can be split. That gives me 6 times 2 times the square root of 2 over 5, which is 12. Square root of 2 over 5. Either way, if you see the simplifying, you're welcome to do it. If not, you don't have to, because you will get the same result in the end. You just have a little bit larger numbers to deal with. Anybody have any questions? Okay. The worksheet I gave you is your homework. Tomorrow we're going to go to adding and subtracting them. And then we still have our our quiz next Friday. Tomorrow, though, we are on pep rally schedule, so we'll be short like 5 minutes or something like that. So.